Hi everyone, my name is Bharati. Today I came with the real numbers chapter to give the complete chapter introduction about that how they are going to ask in the board examination with the different point of questions. Now first real numbers. What are the real numbers here? Rational numbers and irrational numbers combination is nothing but the real numbers. Now rational numbers. What are the rational number? The numbers which can be written in the form of P by Q. The numbers which can be written in the form of P by Q, where Q is not equal to 0. Those numbers are rational numbers. So for that what we can give the example actually, we can give minus 1 by 2 is a rational number and P comma Q is belongs to integers. P comma Q is belongs to integers. Minus integers means both negative and positive numbers comes under the integers. So minus 1 by 2 is a rational number? Yes. 2 is a rational number? Yes. Because 2 we can write as what? 2 by 1. It is in the form of P by Q. Okay. Now what about the irrational numbers? Irrational numbers which cannot be written in the form of P by Q. Numbers which cannot be written in the form of P by Q. Those numbers are called irrational numbers. What we can give the example? We can give the different type of examples. Nothing but example. Pi is an irrational number. Okay. What we can give the example? Pi is an irrational number. Now, once we go with the chapter, how they are going to ask with the questions. In the real numbers chapter in 10th standard point of view, we have the mainly with the HCF and LCM. To find out the HCF and LCM, we'll see with one question here. Now, express 140 as the product of its prime numbers. First question what I am doing here. Express 140 as the product of its prime factors. Okay. Now, in this here, product of its prime factors, in this they are asking us to write down the product of prime factors. That means we need to use with the prime numbers. As we know the prime factorization 140 here. So, we can write as 2 7s are 40 as 2 is a prime number and 2 35s are 70 and 5 7s are and 7 1s are. That means 140 is equal to 2. How many times it was repeated? 2 times. So it is in the powers of 2 power 2 and 5 is repeated only 1 time. So 5 power 1 and into 7 power 1. So 140 is the product of its prime factor means is equal to 2 power 2 into 5 power 1 into 7 power 1. Now we'll go with the HCF and LCM. The last question we have seen with the how to find out the product of its prime numbers by using with the prime factorization. Now mainly here we have to look into the how to find out the HCF and LCM of the given numbers. To find out the HCF and LCM of the given numbers, let's go with the prime factorization. Here we have with the 3 different numbers. We'll do the prime factorization. So prime factorization of 12 is nothing but 2 6s are 12, 2 3s are and 3 1s are, and 15 we can write as 3 5s are and 5 1s are, and next 21 is nothing but 3 7s are and 7 1s are here. Now how will we can write with the product of its prime factors means now 12 is nothing but what? 2 power 2 and 3 power 1, and 15 we can write as what? 3 power 1 and 5 power 1, and 21 is nothing but 3 power 1 into 7 power 1. Correct? Now, if you observe the prime factors here, we have the how many types of different numbers we have in the different 3 numbers. 2, 3, 5, 7. Correct? 2, 3, 5, 7. Here, in the different numbers, here we have with the 2 and 3. What number we have missed here? So, 5 and 7. So, let's write without changing the value. So, 5 can be written as 5 power 0. Yes, and 7 we can write as 7 power 0 because any number to the power 0 is what? It represents 1. We did not change the value here. Now 3 and 5 is there. Now, what are the numbers I have to write here? 2 and 7. So, we can write 2 is nothing but 2 power 0 and here 7 power 0 here. Now, in 21, we have with 3 power 1 and 7 power 1. So, I need with the 2, 3, 5, 7 as we have the different numbers. We have 3 and 7. So, I need 2 and 5 also. So, 2 power 0 into 5 power 0. Now, all the values we have here. Now, HCF. HCF of 12, 15 and 21. Here, as we know the definition, here HCF means highest common factor. But in the given number, which is having with the highest common factor, but we'll take with the least power of the given numbers. In twos, which is the least power? In twos, which is the least power? 2 power 0. So, 2 power 0. In threes, which is the least power? 3 power 1. And in 7, which is the least power? 7 power 0. Now, 2 power 0 is what? 1. 1 into 3 into 1. So, the HCF is what here? 3 is the HCF. And here, so in 2s we have seen with the 2 power 0 and 3s we have see with the 3 power 1 and in 5s we have with the least power 5 power 0 and in 7s we have with 7 power 0. So 2 power 0 is nothing but 1. 1 into 3 into 1 into 1. So it is nothing but is we need to go with the highest powers of the numbers. Which is the highest power? In the 2s, the highest power of 2 is what? 2 power 2. In 3s, which is the highest power? 3 power 1. In 5s, which is the highest power? 5 power 1. And 7, it is 7 power 1. So 2 square is nothing but 2 into 2, right? Yes. So 4 into 3 into 5 into 7. 4 3s are 12. 5 7s are 35. So 12 into 35. 12 into 35 is nothing but what? 420. So the LCM of 12, 15 and 21 is what? 420. We remember always when you are finding the HCF and LCM of the given numbers, HCF means we need to take with the least powers of the numbers and LCM means we should take with the highest powers of the number. Okay. Now we have seen with the numerical values how to find out the HCM and LCM of the given numbers. Now they will give with the variables like A is a one number, that prime factorization x cube y square, we got it, and B is the number with the prime factorization x square y, we got it. Then they are asking us to find out the HCF and LCM of the given numbers. Now HCF of A and B. What are the numbers we have? A and B. So HCF of A and B as our definition. What did I say here? HCF means we have to take with the least powers. Correct? In X, which is the least power? X square. And in Y's, which is the least power? Y power 1. So the HCF of A and B is what? X square into Y power 1. Now LCM. LCM of A comma B. LCM means we should take with the highest powers. What is the highest power in x cube and x square? Yes, x cube is the highest power. In y, which is the highest power? Y square is the highest power. So the HCF of the given numbers is x square into y to the power 1 and LCM of A comma B is equal to x cube into y square. So now I'll give some keywords about the here. Prime number. What is a prime number actually? The definition of a prime number is it is having exactly two factors, one and itself. Exactly two factors, one and itself. One and the number itself. So example what we can give? 2 is the prime number. 2 is the even prime number also we can tell. Only one even prime number we have. Two factors are what? 1 comma 2. 1 is the number it is and itself means what? 2 itself. So what are the factors of 2? 1 comma 2. 1 and the number itself. So the factors of 2 is 1 comma 2. So it is a prime number. And exactly one prime factor. One more what we can give? Exactly one prime factor. Exactly 1 prime factor here. So as we understood, prime number is what? Exactly 2 factors, 1 and the number itself. So example we can say 2 and what are the factors? 1 comma 2. And as per one more definition what we can give, exactly 1 prime factor, that is called what? Prime number. Correct? Now let's see with some examples. They can ask the questions like this. Now what is the HCF of least prime number and even prime number? What is the HCF of least prime number and even prime number? First of all, let's see some important points here. Least prime number. What is the least prime number actually? What is the least prime number? 2 is the least prime number and even prime number. Even prime number. What is the even prime number? 2 is the even prime number and least odd prime number. So least odd prime number. Least odd prime number is what? 3 is the least odd prime number. Greatest 1 digit odd prime number. Greatest 1 digit odd prime number. Greatest 1 digit odd prime. Greatest 1 digit odd prime is what? 7. 7 is the greatest 1 digit odd prime number. Least 2 digit prime number. Least 2 digit prime number. Least 2 digit prime number is what? Yes. So least 2 digit prime number is what? 11. Next one, greatest 2 digit prime number. Greatest 2 digit prime number. Greatest 2 digit prime number. It is nothing but 97. Okay, we should not write 99. 99 is a composite number. Greatest 2 digit prime number is what? 97. So how they are going to ask the question here? What is the HCF of least prime number and even prime number? So HCF of least prime number and even prime number is what? Least prime number is 2. Even prime number is what? 2. So the HCF of 2 comma 2 is what? 1. Correct? So like that. And one more question. What is the HCF of least odd prime number and greatest 1 digit odd prime number? So least odd prime number what? 3 and greatest 1 digit odd prime number is what? 7. So 3 comma 7 HCF is what? 1. Okay, so like that they can ask with the here find the HCF and do the subtraction of HCF minus LCM, LCM minus HCF. Like that they can ask the questions here. Now we have seen with the prime numbers. Now some keywords I will do with the composite numbers. Now just now we have discussed about what? Prime number. Okay, now let's see about the composite number. What is the composite number? It having the more than 2 factors. What is that? More than 2 factors. It is called what? Composite numbers. In that, so what are the questions they can ask here? What is the least composite number? Least composite number. What is the least composite number? What is the least composite number? Yes, 4 is the least composite number. Next one, greatest 1 digit composite number. Greatest 1 digit composite number. What is the greatest 1 digit composite number here? 9 is the greatest 1 digit composite number. Next one, least 2 digit composite number. Least 2 digit composite number. 2 digit composite number. What is the least 2 digit composite number? 10, right? Yes. Next one, greatest 2-digit composite number. Greatest 2-digit composite number. Yes. So 99 is the greatest 2-digit composite number. Okay. Next one, what are the co-primes? Yes, it is having the common factor only one. It is called the co-prime numbers. Let's see one question how they are going to ask in the examination. So find the LCM of the smallest odd prime number and the greatest 2-digit number. As we know, smallest solution here, smallest odd prime. What is the smallest odd prime? It is 3. And the greatest 2-digit number. Greatest 2-digit number. Greatest 2-digit number. It is what? 99. So we should find out the LCM of 3, 99. So let's go with the factors of 3. What we can write the factors of 3? It's nothing but, so prime factorization, 3 ones are 3. In the same way, 99 means what? 3 3s are 3 3s are 3 11s are 11 ones are. So 3 is equal to 3 into 1, and 99 is nothing but what? 3 power 2 into 11 power 1 into 1. So LCM means, what did I say here? It should be with the, here 3 into 1, it's nothing but here 11 power 0, and here 1 we can write. Now LCM means we should go with the highest powers. In 3s, which is the highest power? 3 square. In 3s, which is the highest power? 3 square. In 11s, which is the highest power? 11. So 3 square is what? 9. 9 into 11, 99. So the answer for the LCM of 3 and 99 is what? 99. So one more important question in the real numbers. Check whether 6 power n can end with the digit 0 for any natural number here. Okay. Now what is the prime factorization here? 6 power n means we can write as 2 into 3 power n. Correct, right? It's nothing but 2 power n into 3 power n. As we know, to end with the 0, we need the factors of both 2 and 5. Both 2 and 5 is there only, the number can end with digit 0. But the prime factorization of 6 power n, it has the 2 as the factor, but we don't have the 5 as the factor. So it will not end with 0. As I said here, 6 power n we can write as the 2 power n into 3 power n. So it should have the both factors of 2 and 5 to end with the digit 0. But we have with what? Only 2 as the factor here. There is no 5 as the factor here. So it does not end with digit. Prime in factorization of 6 power n are 2 and 3. For 6 power n to end in the digit 0, prime factorization of 6 power n should contain the prime factor 5. So therefore 6 power cannot end with 0. So I hope everybody is liking my video. I am going to give the more questions on the real numbers in the coming video, next video. So please like, share and subscribe it. Thank you.